everybody. This lesson today is going to be the first half of the class notes for lesson number 4. On Moodle, you're going to see this document here posted, and I will post a blank version of both the study guide and intervention for 8.6, Law of Sines and Cosines. The first side is Law of Sines, the second side is Law of Cosines. So these will be blank posted and filled in with the solutions posted. This video is only going to cover the law of sines, and so that's just the first half of this. So essentially, what the law of sines will allow us to do, and I'm going to zoom in on this part right here, is it's going to allow us to find the sides or angles in a triangle. But it doesn't have to be a right triangle like it does for sine, cosine, and tangent when we do opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So we don't use SOHCAHTOA for this, and the only way we can use SOHCAHTOA is if we have a right triangle. So what do you do when you don't have one? We use this. Or we're going to use the law of cosines. It depends on what information you're given. So I'm looking at this problem right here, trying to get a little more focused. And what I'm going to do is deviate from this worksheet, but I want you guys to know that this is available, and then I'm going to jump down and do examples 1, 3, and 5 here in just a few minutes. So essentially, if I have a triangle, and I'm going to go ahead and just draw one. This one is not on your worksheet or anything like that. Okay, I'm just starting off with, a triangle. And I'm calling this vertice A, B, and C. And again, the sides opposite those angles are named with lowercase letters, just like this. So the angles have the uppercase letters, and the lowercase letters go with the sides. The way the law of sines works is like this. You can pick any angle you want. I'll start with angle A. If you take the sine of that angle and divide it by its opposite side, therefore making a ratio, that will equal, you could pick any of the other two angles, I'm going to choose B, the sine of angle B divided by its opposite side, and that will also equal the sine of angle C divided by its opposite side. This is called an extended proportion. So all three of these ratios are equal to each other. Now when you're solving one of these problems, when we start to put numbers in here, you're only going to use a proportion, not an extended one. So let's just jump right into a problem and see how this works. But actually, before we do, I want you to remember that you don't have to put the angles on top all the time. So let's say, for instance, I wanted to find side A. I could say, oh, okay, well, A over sine of big A, side over angle. Up here, I'm doing angle over side, so all of the other ones have to be angle over side. But I can reverse them and say side over angle equals side over the sine of the angle, and this side over the sine of its opposite angle. So just keep that in mind. Depending on what you're looking for, we'll determine which one of these is easiest to use. So on this paper right here, and again, these two problems up here are already worked out for you, and they give you a little bit of an explanation next to it. I'm going to jump down to problem number 1, and it's very difficult for you to see these numbers. So what I'm going to do, I'm going to try to zoom in here a little bit. It's a little better, but focusing it is the greatest. But here we go. I will let you know what these angle measures are. Here's my side X. That course is 12. That looks like it's coming out clear. Here's a 40, and this angle here is 80 degrees. So if I want to find X, that's a side. So I'm going to put my X first. X over the side opposite is 80 degrees. So I have the sine of 80. That's going to be equal to, now I look at my picture, and the only other side I have is 12. So I do 12 over, the angle opposite 12 is 40. So 12 over the sine of 40. And now I just have an algebra problem where I can take cross products. And I can do x sine 40 is equal to 12 sine 80. To get x alone, you divide both sides by sine 40. Now be careful when you do that you don't divide these two and think that you're going to take the sine of 2. These are two different numbers. You have to calculate those first. And so I will show you the keystrokes for this on the calculator, and then subsequent problems, I'll just work them out and then write the answers down here for you. But remember, you need to be in degrees. Okay, so always check that on your calculator. So now the problem that I'm working out is 12 times the sine of 80, and you can end that parenthesis or hit enter right now. I like to hit enter. And then divide by the sine of 40. The reason I like to hit enter is because then I don't have to worry about missing a parenthesis. And your answer here is going to be 18 point, and then we have a lot of digits. So make sure that you double check what you're asked to round to. This problem, it's the tenths, so your answer will be 18.4. So x is equal to 18.4. Let's take a peek at number 3 over here. Now I realize that one's even a little more difficult to see these numbers. So what I have here is x. This measure here is a 16. This angle down here is 84. And this angle in here is 34. So I'm looking for a side. So I take x over, the angle opposite is 84 degrees. So the sine of 84 is equal to, now since this is not a right triangle, there's no way I can find this side because I have two missing sides right now. So I can't use Pythagorean theorem. So I'm going to continue with my law of sines. So I have to use my 16. So 16 over the sine of what? Because this angle down here is this angle that's opposite that side. Well, my triangle angle sum theorem says that all three angles have to be 180. So 84 plus 34 is 118. And if I take that from 180, this angle down here has to be 62 degrees. So I have to take the sine of 62 over here. And then I'll work this problem just the way I worked the other one. However, the difference is I'm not going to do cross products this time. There's actually a quicker way. If I multiply both sides by the sine of 84, it drops here. And then I just put it up here. So it's just one less step, and you're allowed to do that, of course. So in this case, x is going to equal 16 times the sine of 84, and then I will divide that by the sine of 62. And that answer looks like this, the number there. Since I'm rounding to the tenths, the 2 does not round it up, so my final answer will be 18.0. Since it says the tenths, I should hold the place. And the last example for this page on the law of sines is going to be problem number 5. Now in this problem, I'm looking for this side. Keep in mind, it's not a hypotenuse because these angles are not 90 degrees. This one's 89 up here, and this one here is 80. So I'm looking for x. X over the opposite angle is 89. So the sine of 89 is equal to this side, which is 12, over the sine of 80. Now if I take my little quick shortcut from before, I can multiply both sides by sine 89, which means x is going to equal 12 times the sine of 89 divided by the sine of 80. And when I work that out, my final answer is going to look like this right here. and that's going to be 12.2. So x equals 12.2. Now I have posted a homework sheet where the first 6 problems deal with the law of sines. The second 6 deal with the law of cosines, which is in the next video. Again, I'm posting all of the answers for this worksheet on Moodle along with the blank copy of this worksheet as well. So please feel free to work out numbers 2, 4, and 6, and you could even try 1, 3, and 5 again, just until you're comfortable with this. After you've worked a few out, go ahead and try your homework. Good luck, and if you get stuck or you have any questions for me, don't forget to email. Have a great day. Hopefully we'll get to see each other soon, and I hope you're all healthy.